If you've been paying any attention to the tech world recently, you've probably felt a bit overwhelmed. You're hearing terms like agentic AI, RAG, LangChain, and Copilots getting thrown around everywhere. It feels like a massive paradigm shift is happening right under our noses. And honestly, it is. But today, we're going to completely demystify it. Based on foundational research from Google and looking at where the modern AI ecosystem is actually heading, we're going to break down exactly what AI agents are, and we're going to do it completely jargon-free. So let's jump in. To understand where we're going, we first need to validate why everyone is so confused right now. For the past couple of years, we've all been fascinated by standard AI chatbots. But standard large language models, or LLMs, have a really major limitation. They are essentially trapped in a vacuum. Think about it. They can only predict the next word based on a static set of training data. They can't check today's weather, they can't book you a flight, and they can't actually do anything for you in the real world. By the way, if you want to stay ahead of the curve on paradigm-shifting tech like this, taking a second to hit subscribe to our Explainer series is a great move. Okay, let's dive right into the core difference because it's actually pretty clear once you see it. A standard model is static. You give it a prompt, it gives you a single prediction, it has incredibly limited memory, and zero native tools. An agent, on the other hand, is dynamic. It manages a continuous context, meaning it actually remembers the flow of a multi-step conversation, and crucially, it connects to external tools to interact with the real world. Simply put, a model just talks, an agent acts.
Section 1. What exactly is an AI agent?
Let's ground this highly technical concept into a relatable mental model. I want you to picture an AI agent as a master chef working in a busy, high-end kitchen. A standard AI model, that's just a cookbook. It knows all the recipes, sure, but it just sits on the shelf. The agent is the actual chef. First, our chef gathers information, checking the pantry for ingredients and taking the customer's order. Second, the chef reasons and plans, deciding how to combine flavors based on what's actually available. And finally, the chef executes, chopping, blending, and cooking. And here's the magic. If they taste the sauce and it needs a little more salt, they adjust on the fly. An AI agent actively takes in information, plans out a sequence of steps, and takes real action to reach a specific goal.
Now, what's really fascinating is how perfectly that chef analogy translates into actual software architecture. Look at these three essential components. They make up the agent's brain and body. At the bottom, you have the model. This is the underlying intelligence, our chef's culinary knowledge. Over on the right, you have the tools. These are the knives, pans, and ingredients that let it actually interact with the outside world. And right there in the middle, in the green box, you have orchestration. This is the agent's working memory and its reasoning engine. It's the central nervous system connecting the big brain to the active hands.
Section 2. Inside the cognitive architecture.
So how does this system actually think? Well, that orchestration layer we just looked at is the absolute engine of the agent. Unlike a standard chatbot that just fires back a single answer and stops, orchestration is a continuous, cyclical loop. The agent takes in your prompt, performs internal reasoning, decides on an action, looks at the result of that action, and then it reasons again. It runs this loop continuously until your overarching goal is finally met.
One of the most popular ways developers structure this orchestration is called the REACT framework. It stands for Reason and Act, and it's a beautifully simple loop. First, a question comes in from the user. Second, the agent generates an internal thought about how to solve it. Third, it takes an action, like triggering a web search. Fourth, it makes an observation based on what that search returned. And from that observation, it loops right back to a brand new thought, iterating over and over until it has the perfect final answer. Let's actually look at this in practice, because this brilliantly illustrates the difference. Let's say you tell the AI, I want to book a flight from Austin to Zurich. Instead of just guessing, the agent has an internal thought. I should probably search for flights. It then takes the action of calling a flights tool. It observes the massive list of real-time flight options that tool brings back. It thinks, okay, I should present these to the user, and finally it delivers an accurate, factual answer. It didn't hallucinate a guess, it actively reasoned its way to a real solution.
Section 3. Connecting to the world. We've spent some time talking about the brain, but how does the AI actually reach out and touch the internet? Well, as the Google research clearly states, foundational models remain constrained by their inability to interact with the outside world. Tools bridge this gap. Tools are literally the hands of our AI chef. They allow the agent to pull live weather data, control your smart home, or query your private corporate database. Real quick, before we look at the specific types of tools, head down to the comments right now and let me know, What is the #1 tedious task at your job that you wish an AI agent could just automate for you? I'd love to read through those and see what you all come up with. All right, looking at the modern AI ecosystem, tools generally fall into three primary categories: extensions, functions, and data stores. Let's keep the technical jargon to an absolute minimum here. Extensions are executed by the agent itself to control public APIs. Essentially, they are digital bridges that let software talk to other software. Functions are executed on the client side, which gives the app developer total control. And data stores give the agent access to private, real-time documents. Let's break these down one by one because it's super important. First up, extensions. Think of these as pre-built bridges. You provide the agent with examples of how an external API works. When a user asks a question, the agent's internal reasoning loop automatically decides which extension to use. In this example, the agent seamlessly chooses between a Flights API, a Maps API, or a Weather API, directly calling the specific endpoint it needs to solve the user's exact problem. Now, contrast that with functions. Sometimes, for security or data flow reasons, a developer doesn't want the AI agent making live API calls directly on its own. Enter function calling. If a user asks for a ski trip recommendation, the AI agent doesn't actually book the trip. Instead, it outputs a perfectly structured piece of JSON data. Think of it like a highly organized digital checklist containing the desired cities and preferences. Your client-side application then intercepts that data and makes the API call to Google Places itself. The model does the smart thinking, your application keeps total control of the execution. So the crucial point here is understanding the third category, data stores. Going back to our chef analogy, if standard training data is a static, dusty library of old recipes, data stores are like giving our chef a massive, continuously updated, real-time digital cookbook. By using vector databases, which basically act like incredibly smart, searchable filing systems, agents can read your private PDFs, company spreadsheets, or live websites. And they can do all of this without needing expensive, time-consuming model retraining. This is exactly what the industry calls retrieval augmented generation, or RAG. You've probably heard that term. For example, if a user asks an agent, "What is our parental leave policy?" a standard AI model would just invent a generic, generalized policy. But a RAG-enabled agent performs a vector search against a private PDF data store. It retrieves the exact snippet of your company's actual HR manual, feeds that real data into its orchestration loop, and outputs a 100% accurate factual answer. It fetches reality before it speaks. Section 4, Building Real-World Agents. We've covered a lot of theory, but how do we actually deploy these things? To make an agent truly useful, it needs targeted learning. Let's bring our chef back one last time. You can use in-context learning, which is like asking a chef to cook a brand new dish on the fly just by handing them a recipe prompt. You can use retrieval-based learning, like the RAG we just talked about, which gives the chef a highly stocked pantry of real-time ingredients to pull from. Or, for highly specialized, complex tasks, you can use fine-tuning, which is literally sending your AI chef back to culinary school so they deeply internalize a specific, nuanced domain before they ever step foot in your kitchen. To actually build these robust systems, developers are turning to some really powerful frameworks. Open-source libraries like LangChain and LangGraph, alongside enterprise-managed platforms like Google's Vertex AI, serve as the actual kitchens where these AI chefs are built, tested, and deployed into production. These platforms handle all the complicated orchestration, memory management, and tool integration behind the scenes, letting developers focus entirely on creating incredible, seamless user experiences. Let's move to the future and see where this is all heading. We are rapidly moving towards something called agent chaining, or multi-agent systems. Imagine not just having one single chef, but an entire autonomous kitchen staff. A primary manager agent receives a massive, highly complex goal from you. It then seamlessly breaks that goal down, delegating specific subtasks to specialized subagents. One handles data analysis, another writes the code, another sends out the emails. They communicate with each other, they correct each other, and they achieve things a single model simply never could. Which leaves us with a final and honestly super empowering question. What previously impossible task will you delegate to your first AI agent? We are no longer just chatting with AI, we are orchestrating it to take real action on our behalf. Thank you so much for joining me in this explainer. If you found this breakdown valuable and you want to keep mastering this rapidly evolving AI landscape, please hit that subscribe button, give this explainer a like, and absolutely share it with a colleague who needs to get up to speed. I'll see you in the next one.